Are you ready for a spectacular cosmic event that will soon grace the night sky? Astronomers predict a recurring nova show in the T Corona Borealis or T CrB binary star system, also known as the Blaze star. The T CrB binary star system, located in the lower left corner of the constellation Corona Borealis, provides a dazzling celestial fireworks display that is briefly visible to the naked eye about every 80 years. The gravitational tug between a red giant and a white dwarf star orbiting close to each other is known to be the cause of this event. The material ejected by the white dwarf star from the red giant star triggers thermonuclear reactions on the surface of the white dwarf star, leading to a bright explosion that can be observed even from Earth, 3,000 light-years away. In this video we will discuss the historical observational record of T CrB, the nature and mechanism of this recurrent nova explosion, and how to observe this event in the night sky. This rare event occurs far enough away from us to pose no threat. It's also important because you'll only have the chance to see it with the naked eye once in your lifetime. Although it actually happened thousands of years ago, the enormous flare created by the T CrB nova will reach us in the very near future. Because of its great distance, the T CrB binary star system consisting of a red giant and a white dwarf is a faint dot even through binoculars. The explosion of the white dwarf star will cause a sudden brightening of the system, increasing its brightness from +10 to +2 magnitudes, about the brightness of the North Pole star Polaris. Before we continue, if you subscribe to our channel and like the video, you will support and motivate us to publish next videos. So how is it that astronomers can predict in advance that an event that will take place at such a great distance could occur within a few months? A few months may seem like a long time to make a prediction, but on an astronomical scale it's a very narrow window of time. Let's talk about how astronomers predicted this event with the help of historical records. The first records of this celestial event date back to the 13th century. In 1217, the abbot of Erzberg Abbey in Germany recorded an unusual brightness near Corona Borealis, marking the first observation of T CrB. In 1787, Francis Wollaston noted a similar event, documenting its coordinates and hypothesizing it was a star. The next observation in 1866 led astronomers to predict a nova explosion in February 1946, which occurred as expected. These events, recurring every 80 years, are now known to be thermonuclear explosions 3,000 light-years away. As mentioned before, T CrB is a binary star system consisting of a red giant and a white dwarf star. When these orbiting stars are observed with advanced telescopes from Earth, the brightness of this system periodically increases and decreases. This is because the white dwarf star blocks the light of the red giant as it passes in front of it. We can clearly observe the brightness change of this binary star, which orbits each other for about 220 days. Data from 1946 shows a slight increase in the brightness of T CrB in the last 10 years before the explosion, and then a significant decrease in brightness a few months before the explosion. Immediately after this decrease, a nova explosion occurred within a few months, which could be seen with the naked eye from Earth. This 1946 data sheds light on the understanding of today's observational data. Because just like in 1946, the brightness of T CrB has increased in the last 10 years, and it has decreased significantly since April 2023, reaching the lowest level. We can say that this low level is the most important sign that the nova explosion may take place between May and September 2024. In fact, this event is expected to occur in 2026. But this serious decrease in brightness indicates that the explosion will take place in the second half of 2024. The mechanism of nova explosions is not yet fully understood. Astronomers can give very precise dates for when this event will occur from the brightness change, but the physical processes that cause this brightness change are not yet clear. It is thought that the decrease in brightness may have been caused by a gas outflow in the star before the explosion, but no clear observations have been made yet. Let's take a closer look at this nova event and explain how it differs from a similar process Type 1a supernova. Nova, Type 1a supernova and Type 2 supernova are all celestial events characterized by a sudden increase in brightness in the sky, often resulting in the death of stars. However, they differ from each other due to their different mechanisms and the types of stars in which they occur. Novae are events that occur in binary star systems, where one star is a white dwarf and the other a main sequence star. White dwarfs pull material from their companion star, which is usually a red giant, under the influence of gravity and begin to deposit it on their surface. This material, which is predominantly hydrogen, initiates a thermonuclear reaction in the white dwarf, leading to explosions and a sudden increase in brightness that can be observed at great distances from the system. This is a temporary flare that fades after about 1 to 2 weeks until the thermonuclear reactions are over. Even though the white dwarf that is not destroyed by this event loses some mass, it continues to steal material from its companion star, and this happens periodically over time. One of the best examples of this event is the T CrB nova, as it can be seen with the naked eye. Occurring once every 80 years, this nova is expected to occur at any time in the coming months. Type 1a supernovae, like novae, contain white dwarf stars, but unlike novae, the carbon-oxygen-rich white dwarf in the binary system draws material from its companion star, and when it reaches a critical mass called the Chandrasekhar limit, it initiates nuclear fusion reactions and produces an explosion so violent that it illuminates the entire galaxy. As a result, unlike in novae, the white dwarf star is completely destroyed. Because of their consistent luminosity variations, Type 1a supernovae are a valuable tool for measuring cosmological distances. A good example of a Type 1a supernova is the SN 2018 GV supernova that occurred in the galaxy NGC 2525 in 2018. This event was observed in detail, and the data was recorded. Type 2 supernovae are the result of the collapse of the cores of very massive stars near the end of their lives. When these stars run out of hydrogen, which causes nuclear reactions, the balance between inflation and collapse is disturbed. Since the star cannot carry out a nuclear reaction and cannot inflate anymore, it cannot support its own weight and begins to collapse towards its core due to gravity. The collapse of the core causes a very violent and bright explosion that hurls the outer layers of the star into space. The explosion results in the formation of a neutron star or a black hole, depending on the mass of the dying star. In addition, the material scattered into space forms a structure called a nebula. This event is visible even from other galaxies because of the brightness of the violent explosion. The supernova of 1054 is a good example of this type of supernova. At the time of its occurrence, the supernova was as bright as the moon in the night sky and graced the sky for several months. It was recorded by Chinese and some Middle Eastern astronomers and also left behind the famous CrB nebula. Now let's talk about where and how to observe the T CrB nova in the night sky, which is expected to occur in the coming months. To find the T CrB nova, we first need to find the constellation Corona Borealis, where the nova will occur. Corona Borealis is made up of relatively faint stars, so it will be difficult to find it at first glance. For this, we will use auxiliary constellations and stars. The best example of a companion constellation is the Dipper-shaped asterism, also known Big Dipper, in the constellation of the Great Bear, Ursa Major in Latin. You can easily spot the Big Dipper in the night sky by looking north. First of all, after recognizing the Dipper shape, find the 3 stars that form the handle of the Dipper in the form of an arc. Following this arc form, you will see Arcturus, one of the brightest stars of the constellation Boötes and the sky. After finding Arcturus, you may notice the kite or ice cream shape that forms the constellation Boötes. Then, in the upper left corner of this kite shape, you can finally see the constellation Corona Borealis, which forms a crown of faint stars. It is in the lower left corner of this crown-shaped constellation that you will be able to see the T CrB nova as it occurs. Since this event will take about 1 week, it will easily offer you the chance to observe it. You will witness that the nova's brightness increases in a short period of time and slowly fades within a week. We strongly recommend you witness this event, which you can observe only once in your lifetime. Since the event is likely to occur in good weather conditions during the summer season, we recommend that you go to rural areas outside the city, away from light pollution. This event can be observed with the naked eye, and even better with simple binoculars or a telescope. Make plans now for this sudden cosmic feast. Thank you for watching the video till the end. Don't forget to like the video and subscribe the channel to support us. Stay tuned for our next videos.